In this problem, the function 3x squared plus 2x minus 1 and the derivative, we have to use the first principle of differentiation, right? So, indeed, the first principle of differentiation phenomenon by the definition f prime x is equals to limit h tends to 0. Here f of x plus h minus f of x and h. Now let's plug in the value of the function limit h tends to 0. So plug in the value of function of f x plus h. Instead of x, we have to plug in the value of x plus h. So 3 x plus h whole square plus 2 times x plus h and then minus 1 and minus, let's use the curly bracket. So f of x means 3 x square plus 2x minus 1 and then curly complete tends to h tends to 0. So limit h tends to 0. So here we have to use the algebraic formula a plus b whole square. So 3 times, let's use the first bracket. So x square plus 2xh plus h square plus 2x plus 2 of h minus 1 and minus 3 x square minus 2x plus 1. So this one cancel out each other and 2x cancel out. The following line will be limit h tends to 0. Here 3x square plus 6 xh plus 3h square plus 2 of h minus 3x square. 3x square cancel out. Now the next following line will be h tends to 0. So here our main target to eliminate the h at denominator. So let's common term is h. So 6x plus 3h plus 2 and here will be h. So h's cancel out each other. Now it's time to plug in the value of 0 instead of h because the limit is h tends to 0. Indeed, so here will be 6x plus 3 times 0 plus 2. So the final result will be 3x plus 2. So this is the answer of f prime x, which is actually the derivative of the function f of x 3x squared plus 2x minus 1 by using first principle of differentiation. In this problem, we have to prove that the derivative of kx cube is equals to 3kx square, where k is the constant. That is a very important point. And another point, I mean the condition, we have to use the first principle. Indeed, what is the first principle of a function? So this is the function of f of x is equals to kx cube, right? So by the definition of first principle, f of x, of course the first order principle using for derivative. So here will be 1 prime. So the definition said limit h tends to 0 f of x plus h minus f of x. Now limit h tends to 0, here of course h, and the value of the function f of x equals to kx cube, right? So k, and here function of f of x is equals to kx cube. So we have to plug in the value of x plus h. So x plus h whole cube minus f of x means k x cube. The following line now, limit h tends to 0, here h, k, the basic equation or the rule of a plus b whole cube. So here will be x cube plus 3 x square h plus 3x h square plus h cube minus k of x cube, right? So here what we have to do, we have to simplify the equation unless we can resolve the problem of h. Why I'm saying this h is a big problem here, because if we plug in the value of h is equals to 0, so the whole term will be infinity, which is not our desirable result. Indeed, we have to eliminate the term h, I mean this h. So let's simplify the equation. So this will be k x cube plus 3 x square h plus 3 x h square k plus k of h cube minus k of x cube. So this term cancel out. Limit. Now there is a common term, that is h. So let's take the h as a common part of each of the term. So this will be 3x square, and here I think k is missing, so we have to write down the k here as well. So let's write down k here, plus 3xk and h, pardon, not yet. So this is plus, and now here k h square, and here will be h. So this one cancel out. Now limit h tends to 0, what left? 3 x square k k plus 3 x k h plus k h square. Now it's time to plug in the value of 0 instead of h. So here it will become 0, and here it will become 0 square. So this two term will be 0. What left? So the left part is 3 x square k, right? So what was our question? Our question was to find out the derivative of k x cube is 3k square k x square by using the first principle. So 3 k x square. Let's see what is our result. So our result is 3 3x square k, or we could write down 3k x square. So proved.